Our lesson for today will be looking at chemistry. We'll be looking at basics 104. The topic is naming compounds. Let us start. For this lesson, you will need to use a periodic table, and then if you were watching or if you have watched lesson video, the basics from 101 up to 103, you will know that we have what we call oxidation numbers or charges of elements on the periodic table. So we said that in group number 1 it's 1 plus, group number 2 is 2 plus, group number 3 is 3 plus, 4 plus, we have 3 minus, 2 minus, 1 minus, and 0. This is very important when it comes to naming the compounds or writing a molecular formula when you are given the name of the compound. So basically in this lesson video, we'll be doing the naming of the compounds and how to write the molecular formula when you're given the name of the compound. The best way to understand this is to use multiple of examples. We do examples and then we get familiar with how do we generate molecular formula from the names. But before we look at our first example, I want us to understand these words. In chemistry we have di. Actually the first one is mono. Mono, simply write this down. Mono means single or one. Di means 2. Tri means 3. And tetra means 4. We are going to use this. It's very important when it comes to naming a compound or writing the molecular formula of a compound. Simply know that mono means 1, di means 2, tri means 3, tetra means 4. Now in this case, we have to give a molecular formula of this name. It's calcium bromide. Now you can see that the first part of this name is calcium. It means that the molecular formula will consist of calcium. And then bromide, it comes from bromine. So our molecular formula will have bromine, Br. Now we know that molecular formulas, they normally have numbers here. We call them subscripts. Now how do we determine the subscripts? We are going to use the periodic table. We look at calcium, here is calcium. We look at bromine, here is bromine. Then we look at this group that calcium is in. You can see that the oxidation number is 2 plus. Then we look at bromine, you can see it's 1 minus. Like I said, it's very important to know this. So we say for calcium, it's 2 plus. For bromine, it's 1 minus. The next step that we are going to do, for the sake of explanation, we don't include the signs, we simply put the numbers. We have 2 and 1. Then from here we cross multiply. This trick was covered in one of the basics. So this 1 will come here, this 2 will come here, and then we have CaBr2. So this will be our molecular formula for this name. And then you hear that some would say this is calcium dibromide. Remember that I said di means 2. Since we have 2 atoms of bromine, it's dibromide. And then the reason why we have this IDE, we are going to explain it later when it comes to naming the molecular formula. Let us look at the second example. Our next example is magnesium nitrate. We need to find the molecular formula of magnesium nitrate. So as usual, you can see magnesium will be part of the molecular formula. Then looking at nitrate. Nitrate is a polyatomic ion. One of the basics we did cover these type of ions. So it's very important that you go through those lesson videos before this one. So nitrate, it consists of nitrogen, oxygen, and then the subscript is 3 here. Now we look at the charges. Magnesium is in group number, we can check group number 2. So you can see the oxidation number is 2+. So you're going to have 2+ here. Then you should know that for nitrate, it's always 1-. Now taking it step by step, we have magnesium 2 and nitrate 1. When we cross multiply, since we can see that this polyatomic ion, it already has its own subscript, then we need to introduce a bracket. So we are going to have this, we have 1 here, 1 multiplied by this one, it's simply 1, so we have magnesium. And then for nitrate, we cannot say 2 multiplied by 3. You have to understand that. This NO3 must always be there. We cannot tamper with this number. So we introduce a bracket, and then we write NO3, and then our 2, we are going to put it here. So this will be the molecular formula of magnesium nitrate. For the next one, how about you pause the video, you work out this question, you play the video to verify. Now sodium, we know the symbol is an A. Chloride comes from chlorine, so we have Cl. Looking at the subscripts, periodic table, actually the oxidation numbers I meant. You can see that sodium is in group number 1, so it has 1+. Then chlorine is in group number 7, also has 1-. So that means that we are going to have 1+ and 1-. Now we can just cross multiply. We can see that the molecular formula will be sodium chloride NaCl. I hope you got this one correct. Let us look at the next example. Iron 2 phosphate. The reason why we specify ion, we have a number of ions. We have iron 3, we have iron 1. So phosphate is another polyatomic ion that you should be familiar with. One of the basics, we covered this. So we have iron 2, its oxidation number is 2+, that is why we say it's iron 2. If you are looking at iron 3, you will have 3+. And then we have our polyatomic ion, which is phosphate. By the way, this is the symbol of ion. Phosphate is PO4. That is the molecular formula. Then we look at the charges, we have 2+. Then you should know that the oxidation number of this polyatomic ion is always 3-. Now we said we don't omit the signs. Then when you cross multiply, we're going to have 3 multiplied by, we have 1 here since we don't see any number. Then we have 2 multiplied by this polyatomic ion. Remember that we cannot tamper with this 4. So it will be ion 3, open bracket, PO4, 2. So this is the molecular formula of iron phosphate. Our next example, you can also pause this one, pause the video, work out and play the video. Barium sulfide. So barium would be the part of our molecular formula, and then sulfide comes from sulfur, the symbol is S. Then let us work out the oxidation numbers. Barium is 2 plus, sulfur is 2 minus. So we have barium, sulfur, 2, 2. Then we can see that the subscripts is 1 and 1. So multiply, we are going to have barium 2, sulfur 2. But since the subscripts are the same, most of the compounds we just write BAS. Since we can see the ratio is 2:2, then we might as well divide by, then we are going to have 1 and 1. So this would be the molecular formula of barium sulfide. There is a pre-discussion activity that I will display shortly. Once I display this pre-discussion activity, you pause the video and then you work out the questions, and then you will submit the answers so that you can get the correct answers to verify yours. The sake of this activity is to make sure that you practice what you've learned from this lesson video. That's it for this lesson video. This is Wahula SJ. Thank you very much.